chemical portion of the root. You don't see dehiscence and fenestration on 2D image because it's overlapping with the root, so it's more like a cone beam 3D image type of finding.
For like MRI radiograph stuff, are you wanting us to remember like the dates and like inventors of
No.
certain stuff? Okay. Sweet. Just want to make sure.
But I want you to know if you're looking at that image, if you're looking at an MRI or CT or Condé CT or the slice,
Okay.
it's very visual.
So you don't want us to know like how an MRI works? Like, 'cause there's a decent amount of slide of knowing how it works.
Not there will not be a question directly asking you how does MRI work, and then you have options.
Okay.
But it's information that you have to know.
Okay.
Okay, I guess the 3 questions that I have from the Google whatever try. Attenuation, going over difference between no interaction, absorption, scattered. Okay, yes, so that just review that slide that has all 4 different types of interactions. So a photon of X-ray, when it's exiting the X-ray machine, passing through the patient, it may get no interaction, which means you just go straight out passing through the patient with 0 interaction. All the photon, all the energy reach the sensor, or can be absorbed, which means nothing will reach the sensor, and that will be the radiopaque. If passed through it, that's the radiolucent. And then the scattered is when you got deviated. So the photon will interact with the patient, but then some energy will pass through, but in a different direction. And then you have the 2 different types of scattered radiation. You just need to remember which one does which. But again, very broad. You don't need to go into details on that. That was more midterm type of question.
Is there a way to tell the difference between a radiolucent old restoration and a carry?
Yes. An old restoration, the borders will be super marked and well defined, because again, for you to put the restoration, first you need to remove the caries with a burr, so the walls are very marked. Caries is it's an acid type of interaction, so it's infiltrating through the dentin, so it's irregular. It's a shade of gray, you don't see a clear cut.
And then the other 2 questions are.
Oh, yes. Film, latent image, and film processing, going over characteristics of digital receptors, spatial resolution, latitude, and sensitivity. So it's pretty much the receptors lecture. Latent image is the image that you cannot see yet, because you need to process that for you to develop the film for you to be able to see it. So it's just a receptor was exposed, but you don't have a visible radiograph, because you need to go through the processing phase. On a film, it will be going through the chemicals. On phosphor plate, it will be going through the scanner. So it's what the latent image is, an exposed receptor, but not yet a visible radiograph. Latitude is how a receptor responds to different exposure types. So more or less exposure, depending on the receptor, you may get still a good image. Other types of receptor, you need to get a specific exposure time, otherwise you get a very bright or very dark image. So that's the latitude. A longer latitude will allow you different exposure times to still getting a good radiograph. So usually it's a phosphor plate, and the digital receptors or digital sensors have a better latitude than a film. Film, you need to know the exposure time, because if you do less, it will be super bright. If you do more, it will be super dark, and there is no way to fix the image later, because the film, it's an old type of image. Digital, if you expose more or less a little bit, you can adjust the brightness and contrast. pretty much like what you do with your phone. If you take a
Yeah.
photograph and the image is a little bit darker, you can adjust the settings and save the photograph.
And then for receptors, because I know there's a decent amount of slides about like certain angulation that you approach for like certain spots, whether it's anti, lateral, or whatever. Do you want us to know in all the degrees and everything? That seems a little more specific, but it's
The angulations, no.
okay.
I think not even for the midterm I asked angulations. I
Yeah.
just asked.
What was it?
There's one kind of true 70.
Yeah. So, but it's not the number. It was just like which one is which.
Okay.
But
Great.
you don't need to memorize every single angulation number.
Sweet.
Are there extra handouts for this, the final? Because I know for the midterm we had like a couple of the clinical ones. Like there were those 2 docs.
Oh, like to read on your own?
Mhm.
We
No,
have.
I don't think so.
I haven't seen any so far.
I mean, there is a
There's-
panel on anatomy exercise that I posted the key
Yeah.
answer later. I think that's
And
the
then-
only one.
Was it during your first or second lecture that you linked like 2 websites to like view a bunch of different images, or?
That was the anatomy, I think,
Yeah.
as well.
Yeah. that's
Yeah,
what I was thinking.
that's just for practicing.
Okay.
Did you upload the answer key? I was trying to look for it yesterday for the.
Answer key is in the announcements.
Okay, it's in the announcement.
Yeah, so it's a Kai, one of the announcements is the answer key for that, yes.
Gotcha.
What we learned today in class, the verifying osteitis. Well, we just have to identify if it's verifying osteitis on the radiograph or all of it. She said it was hard to tell.
If I don't give any other information, it will just be verifying osteitis.
Okay, and then you could just get clinical findings.
If I give you clinical findings like, oh, it's draining pus,
Yeah.
so then there will be an abscess.
Okay.
So again, broader picture, just verifying osteitis. If you have clinical information, then